Welcome back to Introducing Polynomials. In this video, we will be exploring the other side of the algebra tiles. You probably noticed that if you flip over the red tile, that it is white on the back. If you flip over the other tiles, they're also white on the back. And that's on purpose. So we actually use both sides of the tiles when we're doing algebra. So let's just take a moment and look just at the red one for now. So if that red one has an area of 1 unit squared, what do you think the opposite side of the tile, the white side of the tile, would represent? Take a moment to think about that. If I were to think about a number line and my 1 unit was placed at 1, the white side of the tile would be placed at the opposite side of 0, but located equidistant from 0 as the 1 is. So it would be located at -1. So the red tile is +1 and the white tile is -1. So place some unit tiles on the table, some of them positive, flip to the red side, and some of them negative, flip to the white side. And what's the value you have on your table? Pause the video while you do that. I'm going to place some tiles on my table. And right now I have 1, 2, 3, and I have a -1. So altogether I have 2. 1 plus -1 would be 0, and then 1 more plus 2 more. If I were to add another -1, there'd be 0 there, there'd be 0 there, and this would be worth 1. Let's say I have a couple extra -1s. These two have a total value of 0. These two have a total value of 0. These two have a total value of 0. So all I have left is -1. Can you place some unit tiles on your table, but still have a total value of 0? Take a moment to think about that and build an example. Let's take a look at what I have on my screen right now. I have a +1 and I have a -1. Those, when added together, equal 0. So right now I have tiles on my table that actually have a total value of 0. If I were to add another set of those, I would still have a total value of 0. 1 plus -1 is equal to 0. If I were to add just a red tile, just a +1, now I don't have a total value of 0. These two equal 0, these two equal 0, and then I have an extra one. So to make sure I keep my table in balance, then I will add another -1 there. So if I keep them in pairs, +1 and a -1, 0 pairs. So I can add as many 0 pairs as I want, and I will always have a total table value of 0. So we've explored the red tile, we've explored +1, and we've explored -1. So knowing what you've just learned and explored, what do you think these represent? Take a moment to think about that. So this tile here, this X tile, is the opposite of my green X tile. So wherever my green X tile is on my number line, the white one will be the opposite side of 0, but equidistant from 0. So let's say my green tile had an area of 5, then my white X tile would have an area of -5. If my green tile had an area of 3, then my white X tile would be the opposite of that, which would be -3. But what if my green tile had an area of -7? Well, then that means my white tile would be opposite of that, which would be +7. What about this one? Well, it follows the exact same rules. So it is the opposite on the number line to wherever x squared is. So if x squared has a value of 7, then -x squared would be -7. It always has the opposite sign of your x squared. So let's take all of that and build a polynomial with it. Pick a number between 5 and 10. I'm going to pick 6. I don't know about you. That's how many tiles you're going to use. So there's actually 6 different tiles up on my screen right now. I've got 3 positive and 3 negative ones. I have to use at least 3 different types of tiles. For me, I might use an x squared, a negative x squared, and a positive one. You decide which 3 types. You could use more than 3 types. You could use all 6 if you want to. And what polynomials can you model with that number of tiles? So the steps are pick a number between 5 and 10. That's how many tiles you have to use altogether. Number 2, you have to use at least 3 different types of tiles. Build that and figure out what is the polynomial that you've just built. So simplify it, and then I'll see you in a minute. So here's what I set up. I picked the number 6, so I'm going to grab 2 positive x squared tiles. I'm going to grab 1 negative x squared tile. I'm going to grab 1 x tile. So I've used at least 3 different tiles so far, and I still need 6 altogether. Another x tile, and a 1. Okay, so I have all of my tiles. So I've got 6 tiles, use 3 different ones. So now what is this? I've got 1x squared, and a negative x squared. So I know that this x squared and this negative x squared minus x squared is 0. So I'm just going to kind of lay them over top of each other so that I know that it equals 0. So I've got x squared plus 2x's plus 1. I have x squared plus 2x's plus 1. So now using the expression that you just created, replace the value of x with 3. What do you end up with? I'm just going to write what I had so I don't forget it. X squared plus 2x plus 1. So I have to go through that and say all of my dimensions of x are actually valued at 3. So what would be the total area of what I built? You need to do the same thing. Pause the video and I'll see you in a minute. So for mine, I have an x squared that has dimensions of 3, plus I have 2 x's, so that means the area of my x would be 3 multiplied by 1, which is 3, and I have 1. 3 squared is 9, so that x squared has an area of 9, plus I had 2 x's with an area of 3, so I have an area of 6 plus 1. So altogether, I have an area of 9, and an area of 6, and an area of 1. 9 plus 6 is 15, plus 1 more is 16. So altogether, I have a total area of 16. Now we're going to go back to that original expression you built. So here's mine, x squared plus 2x plus 1. But this time, instead of x being valued at 3, it's going to be valued at negative 2. Pause the video while you find the area of your polynomial expression if the dimensions are negative 2. So let's figure that out for mine. I've got an x squared with dimensions of negative 2. So my dimensions are negative 2. I have 2 x's that have dimensions of 1 multiplied by negative 2 is negative 2, plus 1 more. Negative 2 squared is 4. 2 multiplied by negative 2 is negative 4, plus 1. 4 subtract 4 is 0, plus 1 is 1. So the area of my polynomial expression is now 1. So that's the end of this video. I hope you found it helpful, and I look forward to seeing you in future videos.